Hello, geometry. This is chapter 7, the beginning of chapter 7, and we're going to get into similarity, and specifically ratios and similar polygons. And before we dive into similarity, there's definitely a lot of vocab that we need to get our head around. And one of the key terms is a proportion. So just a little review. A proportion is a ratio set equal to a ratio. And then you may ask, well, what the heck is a ratio? Well, a ratio is a fraction. One number divided by another number is a ratio. So basically what you're saying is set a fraction equal to a fraction. Well, why does that even matter? Well, let's just back up just one step more. And I want you to look at these following symbols. And this symbol here, and this symbol here, and this symbol here, and this symbol here. And what do they mean? Well, this first symbol, when I was growing up, was the pound key on a phone. Or it might mean a pound, or it might mean the number. Of course, many of you looked at that and thought hashtag, right? So symbols have multiple meanings, as does the letter X. It is the letter X. Sometimes we use it to multiply. Sometimes we use it as a variable. It could be the x-axis, right? This little symbol is an apostrophe, right? It can be used to represent feet. Like if you put the number 9 and then apostrophe, that means 9 feet. It could mean prime. You've seen things like the preimage is A prime is the image. This last one is called a tilde. It's in the upper left-hand corner on your keyboard, and it means similar or close to. Actually, no, it means similar. Approximately is double two of those together, roughly kind of rounded. Similar is just one of those symbols. And what does similar mean in math land? Similar means that you have congruent corresponding angles, meaning the angles and the shapes are the same in the corresponding spots, and the sides are proportional. Well, what the heck does that mean? Take a look at this. I'll tell you what it means. Example 1. Identify congruent angles and corresponding sides. So when I look at this picture, okay, congruent angles. Let's see, G and B are both 90, so G and B are congruent. C is 59 degrees, H is 59 degrees, so those two are congruent. Well, by my third angles theorem, A and J have to have the same measure. They both have to be 31 degrees. So what I've just done is I've identified all three angles are congruent. And again, two polygons are similar if their angles are, corresponding angles are congruent, and then their sides are proportional. So now when we talk about sides, what we're saying is AB, because A goes with J and B goes with G, there it is, AB goes with JG, and BC goes with GH, and CA goes with HJ. And what the heck am I doing? Well, actually what I'm doing is if I put little equal signs in between each one of these, I've just created proportions. I have one ratio set equal to another ratio set equal to another ratio. And guess what? When you do that math, when you actually set this up, it's amazing because what you're saying is, oh, AB is 10 over 5 is 2. 6 over 3 is 2. And 11.6 over 5.8 is 2. So all of these sides are proportional, even equal proportion. Therefore, and I should have a little triangle symbol in front of this too, triangle ABC is similar to triangle JGH. Let that soak in for a second. Actually, let's just try another example. Now, in this case, what I'm saying is I recognize that they have different sizes, but are they similar? Are they proportional, congruent angles? Well, one of the easiest ways to check is, let's just figure out what these base angles are, because these are both isosceles triangles. And if the base angles are the same, I might have enough information to figure it out. Well, what is this base angle? Well, in order to figure out, you could subtract 36 from 180 and then divide it by 2. So both of these angles have to be 72 degrees. Well, guess what? If these two are 72 and that one's 62, there is no way. These are not similar triangles or similar polygons. Okay, that's kind of the name of the game. Let's do one more example. Determine if these triangles are similar? If so, write the similarity ratio. So I need to find the ratio and a similarity statement. So again, when you line this up, you have to be very careful that your angles are in order. And I know L goes with P, which means, and M goes with N. That means J and S are also congruent. So I have the same angles. This is going to work. Also, LM is going to go with PN. So check this out. LM is 75 divided by 30. When I do the math, I get 2.5. When I do JM over SN, I get 45 over 18, and I have a call coming in. Can you believe that during a recording? Right, and of course, my 60 goes with my 24, and that is also 2.5. So that's my similarity ratio, right? Ratio set equal to a ratio is called a proportion. All of this work out to be 2.5. My angles are the same, therefore triangle LMJ is equal or congruent, again, I don't have a congruent symbol handy, to triangle PNS. We're not going to talk about it too much in this section, but next section we're going to talk about something called a scale factor, which means if you had to multiply any one of these side lengths by something to get 30, what would you do? Well, it's interesting because if you multiplied 30 by 2.5, you'd get 75. So how would you figure that out? Let me know if you can figure it out before the next class or lecture. Hey, final example, again, a really good one. And it says a boxcar has the dimensions shown. So here's a real boxcar. It's 9 feet wide, 36.25 feet long. The model of the boxcar is 1.25 wide and got to be longer than it is wide. So find the length of the model to the nearest inch. Well, a model should be a scale model and it should be proportional. So the question is, can you find the scale or just simply set up a proportion? So what you said, or what we've been doing so far, is we're saying this 36.25 goes with X, so you can line them up vertically. Make it into a fraction. Set that fraction. I have two equal signs here. I don't need two equal signs. Set it to this one, 9 divided by 1.25. Now, how do you solve this? Easy. Let me get out my handy-dandy arrow. Let's make it, some of you guys like colors. I'm going to give you colors. Let's use this orange. Cross multiply. Oh, that's crazy. That's not what I wanted at all. Guys, come talk to me here. What's going on? Let's try that again. Sorry for the delay in the video, but I know I don't want you to get all flustered. X times 9 and 1.25 times 36.25. You get 9x equals 45.3125. Divide both sides by 9, you get x is equal to 5.0347, blah, 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 blah. Which is roughly, again, I should have a double tilde sign, which is approximately 5 inches. So hey, that's the name of the game. That's what similarity is and similarity ratios. We're going to go way deeper. This, of course, is the introductory lesson.